Okay, ladies and gentlemen, this is Mr. Edwards. I'm going to talk to you about a couple of things here about graphs. The first thing is setting them up. The second thing is interpreting them once we have data in there, specifically data about speed or velocity. So the first thing that we're going to need is a horizontal axis, a vertical axis. The horizontal axis, the axis that's going from left to right, is the x-axis. And the y-axis, if you can remember that there's two, an x and a y, the y points to the sky, y to the sky. So that's the y-axis. And we can define that more specifically or get a little more specific by talking about the independent variable going on the x-axis. That's the one that it's independent of everything else that's going on. In other words, that is the variable that is going to continue doing what it's doing without being influenced by what is going on over here. On the other hand, there's the dependent variable that goes on the y-axis. This one is completely dependent upon whatever happens down here. So if this goes faster, slower, changes in any way, then this one is going to be affected, versus if this one, this one right here does any type of change, it can't happen unless this changes. So our independent variable for velocity or speed, as we oftentimes will refer to it, is time. The dependent variable is distance. So then we need to take our axes and divide them up, put numbers on them, and these are what we call the intervals. So the interval down on the x-axis here for this example, and this can totally change depending upon the situation. These are half-second intervals. Up here, these are whole meter intervals. Okay? It all depends on your data. So setting up intervals, the spaces are the intervals. And in order to find or determine your intervals, you need to find the largest data for each variable. Remember that, and space these out as much as possible. Remember, you're dealing with a picture here. This is a picture representation of your data. And so you have a big piece of graph paper, you're setting it up. I've seen students take only half or a quarter of their graph paper and make a graph. The more you can spread it out, the less error you're going to have, especially when it comes to plotting your data points accurately when they don't fall exactly on the lines. Okay, now let's say we've got our graphs set up and we collected some data. So here you've got some distance, you've got your time, I calculated the speed for you. So we're going to plot it. So there's our first data point. And we need to write you should always write the coordinate pairs next to your data point, just to communicate effectively. So writing coordinate pairs, you want to make sure that your x-axis is always written first, just like in the alphabet. X comes before y. So there's your x, there's your y. So here's our data point. 2 seconds, 10 meters. Draw your line. You're starting at 0 unless there's a situation that you are starting at a different distance, then you would graph it differently. But for example, we recently went outside and or graphed, if you did this inside, you graphed your data of your motion. You did a slow, medium, fast motion. You started at your starting line, which was 0. The velocity in this case, just take your distance, divide it by your time, you get 5 meters per second. Now what we're trying to do is I'm going to explain to you or show to you, prove to you that a straight line means something. Okay? Whenever you see straight lines, you're going to walk away with knowing that this tells you something about the motion of the object. So there's a second data point. Okay, again, there it is, right there. We're going to follow it down. We get 1 second. Follow it across to the y-axis, we get 5 meters. So we write that coordinate pair, 1, 5. If we calculate the velocity, we get 5 meters per second. So what is that trying to tell us? Well, if you notice, 5 meters per second on this point, 5 meters per second on that point. straight lines mean a constant, unchanging velocity. It doesn't matter where your point is on this line. It's going to be the same. If I picked a dot here, the velocity is 5 meters per second. If I picked a dot down here, 5 meters per second. If I picked a dot up here, the velocity is going to be 5 meters per second. This represents an object that has a constant velocity. Okay, let's plot a second point. Okay, this is the second one, 10 meters in 4 seconds. So we write it as 4, 10, draw the line. Velocity is 2.5 meters per second. Let's take a look and pick another point on that line. 2 seconds, 5 meters. Calculate the velocity, 2.5 meters per second. Those 2 points represent the same velocity. Again, straight lines mean a constant, unchanging velocity. Third point, up here. Draw a line. Oh, I didn't do my little lines here. 7 seconds and 4 meters gives us 0.6 meters per second. Oh, there's my lines, or my lines are coming. 5 seconds, 3 meters. Write the coordinate pairs, calculate the velocity, 0.6 meters per second. Straight lines again mean a constant, unchanging velocity. 0.6 meters, 0.6 meters, same. These are the same, these are the same. Notice I'm comparing points on the same line. I am not comparing points yet between lines, only on the same line to prove to you that a straight line means a constant velocity. Okay, so what does the steepness of the line mean? So we're referring to the angle. As the angle of that line increases, often referred to mathematically as the slope. So 0.6 compared to 2.5 compared to 5, this is the slowest. That's the middle velocity, 2.5. There's the fastest. All this shows you, the only other thing that I want you to realize is the steeper the line, the faster the object is moving. So again, we had 2 situations that you need to be aware of, 2 main ideas. Number 1, every point on a straight line represents the same velocity. Okay, it's all the same, it's constant. The second main idea that you need to be aware of is that the steeper the line, the greater the velocity. The shallower the line, the less velocity it has. Okay, another more precise way of saying that is the greater the slope, the greater the rate of change. This could be velocity, this could be population growth, this could be any graph. It's still going to be the same thing. The steeper the angle, the greater the changes.